I want you to think about what you notice or wonder about the video, any questions you have.
Can you find a pattern between the number of cuts made and the number of iced faces on the cake? So we're going to imagine we have a cake and it has icing. And we're going to find the pattern.
And it's, what information would you need to be able to find out the pattern of a cake, like finding the iced faces in a cake?
Or the sides iced.
Are the sides iced or on here?
What else? The sides?
Prior to the cake being cut, is it all iced? Like the whole cake is
The whole
iced?
cake iced. Would the shape of the cake matter at all?
Yeah, the area
Yeah.
of the cake.
The area of the cake?
Because that cake was like weird looking. It's like curved. It's okay.
If it's stacked, it's gonna be different.
So it's a stacked cake?
Yeah.
Anything else?
Do you mean like if this was like this and this and this and this? These are the faces?
Yeah,
Oh,
it's
so
like the
between
sides of the
sides.
cake, but we want you guys to use the term faces for it. So, yeah, the iced faces, so each part of the cake.
So if you have a typical cake, like a birthday sheet cake, how many iced faces does it typically have?
What?
So if we were to
A sheet cake, you just pour icing on top of the cake. You have
that's
one
one thing.
side.
Okay,
pour
think
icing
about
on
think about something at Walmart. You're thinking about Walmart. You're gonna have icing on the top. You're gonna have icing on the side.
That's why you get corner pieces, because
What
What is the sheet cake?
You bake it with a cake sheet.
And then you put icing on it.
Alright, so the cake that we are gonna have is going to be a rectangle.
Do you know what makes the shape a rectangle? You guys all remember?
It
The
has
side.
all right angles and two sets of equal sides.
Okay. So for this, we got a cake from Walmart that is 8 inches by 9 inches by 8 inches. Sorry.
So that's gonna represent this side is 9 and this side is 9.
Yeah.
because they're gonna
So
be equal.
and on this cake, we have this whole part that's iced, the side part that's iced, this part. So every side of it is iced except for the bottom, obviously. So
Does that even count as a face?
And so our cake is gonna be
the bottom face.
1 inch tall.
Yeah, and it's 1 inch and sorry. right there.
And so to represent our cake, we have the little inch cube. So if you could make, as a table group, make an 8 by 9 cake, and then we'll get started. So far, how many faces does our cake have?
A lot.
5, 2.
It has five faces total?
To start.
5 faces.
Five.
It's how many iced faces? Assume that this cake has icing all over it except for the bottom.
So 5 faces.
Okay. So how many pieces of cake is that right now?
1.
Just 1? Okay, so for 0 cuts, we don't have any cuts yet, so it's 1 piece. And then how many iced faces did you say there were? 5. Okay, so are there any with 4 iced faces? 3, 2, or 1, since we just have 1 piece right now? Okay.
Okay. So if you guys could take out either a piece of paper or if you want to use your cubes, I want you guys to figure out how many pieces and iced faces you'd have if you made 1 cut or 2 cuts. And they can only be in one direction.
In one direction. So
you
here's
can choose horizontally or vertically, but you have to continue cutting it in the same direction.
so yeah, so if we made 1 cut, it would just look like that.
So like you wouldn't count because they're not in that.
And remember, you're paying attention to the number of iced faces, not just the. It has to be all in one direction.
Yeah.
So you can't split it like that. It has to be, if you're going to cut it this way once, you have to cut it that way again.
So we cut it this way. Okay. Okay, so they're together.
Then you have to cut it that way again. So you have to go down this way.
Then it'd be even pieces, right?
No, it doesn't have to.
And then I have to cut it again?
Yeah, but it has to be, the same direction. So that would make it, how many cuts is that then? That's 3. That's 3. So you have to make sure you jump from 1 to 2. So then you could just cut it one more time like that. And then there's that many pieces.
That's 3 cuts.
Oh, how many cuts does it look like there are right now? 2. So 2, yeah. Okay. And then after that, you would go to 3, but you have to find the ice spaces for each cut that you make.
Okay,
So how
going
you have to
back
pay
to two.
attention.
So for one cut is
I'm sorry,
1, 2, 3, 4. Right? One piece. So one. No.
Yeah, make sure you keep into account every single piece that is in the.
Okay, so this is an end piece.
It's your second cut. I want the back groove. Let's see. The back here. I want you to come up and explain what you did.
For the first cut.
So, Imelda, how about you come up?
Well, do you guys feel like you have an understanding of it?
Not yet? No.
So does who thinks that they can explain at least just the first cut? Okay, do you want to come up here and fill out the graph? Sure. So that's when we have it cut right here just down the middle.
Okay, so if we cut our cake, we go from having 1 piece of cake to 2 pieces of cake. And we no longer have 5 iced spaces.
Okay, 3 ice spaces.
And we now have 2 iced spaces because you take your cake. Now you have 2. Oops. So you have your top that's iced, and then your sides, which gives you 4 iced faces. And these insides are never going to be iced because it's the inside of the cake. So you'll never have, you don't have any 3. You just have 2 pieces with 4 iced faces.
So 8.
So yeah, there would be two slices or two. Both pieces have 4 ice faces. Is that what you guys think too?
Yes.
Does anyone come up with anything different than that?
So if you were to make another cut, would anything change?
Yes.
So let's say we made another.
So another cut.
Yeah.
So does someone want to come explain what it would look like on the graph for 2 cuts now?
You have this iced, this iced, this iced, this, and this, right?
So then how many pieces would you have? 3? 3?
5, none. 4, 2, 3, 2.
You only have 3 pieces.
Just 1. No. Yes. And I have 2 of these, right? No,
Well, you have 3 pieces, so you've already marked 3.
3.
Yeah, that represents a slice.
That top part's gonna be iced too.
Okay.
Does everyone agree with that?
Yeah.
I'm confused what you mean by like 5 ice spaces, 3, because there should be a total
How
of
many
11.
pieces?
It's how many pieces have those amount of ice faces.
So not how many faces are iced, but how many pieces.
Because so this has 2 ice faces. That means this 1 piece or 0 pieces have 2 ice faces. It's 1 individual piece. And since this has 3 pieces right now, there's only 3 pieces to disperse with the ice faces. So 2 of them have 4 ice faces because it's the end pieces right here.
Which is 8, and then one of them has 3, which is 11 total ice spaces.
Because you're looking at them as individual pieces once you cut them.
Not number of faces.
Yeah.
We were getting 11 because we were counting how many ice spaces are when you cut it.
Yeah.
That's right.
We're just asking for the individual piece.
Yes, you split them.
Okay, see, I'm that.
This is how you keep track.
Okay. So if we were to make 3, another cut, how many pieces would you have? 4?
We have 14 ice spaces.
You'd have 14 ice spaces. So how many pieces would have 5 ice spaces? None. Would we have any with 4 ice spaces? 2. How many would have 3 ice spaces? 2. Would we have any pieces left over?
No.
Okay. So if we were going to make one last cut, we'll just stop here after that.
So we're just trying to find how many pieces of cake have icing. We're not trying to find the faces that have icing on them.
We are finding the spaces that have icing, because each piece will have a face with icing on it.
That's gonna be 14, right? So I can see that, but I'm trying to figure out, what do you mean by 4 and 3 ice spaces? Like, what does that look like?
One piece of cake. So this is the end piece right here.
Yeah,
So
that's
there's
it.
icing on this top part, icing on this side part, icing on this other side part, and icing on this. And so how many? That's 4 ice spaces on that piece. But this middle piece wouldn't have any icing because it's cut into.
So is that what, 4 times 2 and then 3 times 2 then?
We'll get to that.
Because I'm trying to figure out where you're getting 14 from the 2 and the 2 on the 4 and the 3.
Where are you getting 14?
Because that's how many ice spaces there are.
We're looking at individual slices, not the whole cake as a whole.
Because right now we have, for like a 3 cut one, we'll have 4 pieces. So of the 4 pieces, 2 of them have 4 ice spaces. And then these have 3, so you'd have 2 with 3 ice spaces.
We're not looking at it as a
If you
whole.
added it all together, then you'd find the total number of faces.
If we were,
That's right, 3 times.
But that's not.
That's not what we're looking for right now.
Okay. I'm sorry.
All right, so let's do the last one. So if we had 4 cuts, how many pieces would we have?
5.
Would any have 5? Would any have 4 ice spaces? 2. 3. And then we have no left over.
okay. Does anyone see any kind of pattern with this? Yeah. Why don't you guys take a couple minutes with your group and talk about how you could, what pattern you see in this, or if there is any pattern. So you were looking at the,
Number of just ice spaces, and it's gonna go up by 3
I
each
see.
time. Because 11 for 2
because you guys were taking it as like you were counting them all up together
'cause, like,
versus
this-
individual pieces.
This,
But they shouldn't matter. They should
It
add
might
together.
get, see if you guys can find a formula for that, and then we can compare it to the other one and see if it ends up getting the same answer either way.
Because the number of ice pieces is not going to change whether you do an individual slice or all together.
It's just
They
gonna
should
go
all
up
still be,
so what, at 5 cuts?
5 cuts would be 17.
The whole point of this
ice
is we're trying to see if we pull out a random number like, okay, I'm going to make 12 cuts. You're trying to see if you think like, okay, I'm going to make 12 cuts, if you can figure out how many of those, how many ice spaces there will be per piece. We'll come together and we'll figure out. Okay.
So is anyone wanting to share the pattern that they saw? What pattern did you see?
So the total number of pieces compared to the ice spaces, if you look at the numbers, they add up to each other. So if you have one whole piece, or 2 pieces, you have 1 cut. Oh wait, no, I'm looking at 1 piece. If you have 1 whole piece, you have 5 ice spaces. But if you have 2 pieces, then you have 2 4 ice spaces, and that's it. But like that equals 2. But for 3, you have 2 4 ice spaces and 1 3 ice space, and that equals 3. That equals 3 pieces.
Okay.
Well, that equals 8
2 and 1.
Ice spaces?
plus 3, 8, 9, 10, 11. I see now.
Yeah.
So you're looking at these.
Yeah, I'm looking
And
at
equals
the
that.
number of ice spaces.
Does anyone
Okay.
else notice anything different?
You will always have 2 4 ice spaces because those resemble the ends.
So would that be after you make your cut or before you make your cut when you always have?
So yeah, what about this first one?
So after you make your cut, you'll always have 2 or 4 ice spaces. So that
After
number
the first
stays
cut.
the same. So this,
After the middle of each turn.
Always okay.
You always have 8 because no matter what, you're going to have the end, which is always.
so it's always going to be 2. Anything else?
As the number of pieces increase, the 3 ice spaces goes up to 1.
Okay. Oh, I see what you're saying. So what about these first 2 though?
What about?
Okay, so you're saying if when there's the number of cuts increases, the number of 3 ice spaces
Yeah,
increase.
Except for the 0 and
So why do you think that is?
Because those are
When there's 0.
the middle pieces.
Because
The
those
middle
2
pieces.
pieces, we talked about how there's only 4 ice spaces on the edges. So if
Okay.
you have 2 pieces, then you'll only have 4 ice spaces.
Okay, so that's not, these aren't the end pieces then.
Well, it's minus 1
Yeah,
of
so
the
those-
space, so you're going to have minus 1 of the sides, right?
Melda? Yes. Amanda?
Well, I was trying not to spill anything. I get excited, I'm sorry. Can I try?
Yeah.
Sometimes I don't know how to best explain something in mathematical terms because it's been a while. So I just did. Sorry.
Hey, will you erase that a little bit better?
So I did cuts, and you have 2, 3, 4, and then from your cuts you get how many pieces, right? 3, 4, 5. So, and then you got an end and a middle, the middles, and an end, right? So you always have 4. And then the middles you have only 1, right? Because you have 3 pieces. And then you'll have those. And then, does that make sense?
Yes.
So then we found the constant. So Amilda and I came up with, I think, I don't know. So my N is the cuts. The number of cuts minus 1, because it always went down. So 3 cuts, you get 4 pieces. Did I do that wrong?
No. That's what we got. You add 3 to
Okay,
each
and then
one.
8, right?
Yeah, 8's your 2s, the 4 and the 4.
Yeah. So I think then you can plug any number in. It didn't work with 0.
If you have cuts.
Wait,
What's your N?
N? I don't know. I think I did it backwards.
And you say N was number of
Because
cuts?
like that's the exponential, every time you're saying 3, 3, 3, 3, 3, that's 3.
3
That's 3
times-
squared, that's 3 cubed.
3 minus 1 is 2.
Okay.
I don't know.
So y'all need to tell Alex and Victoria things they did well, hey, something to think about.
What?
It's already.
I thought we had 45
I
minutes.
need more answers.
You wanna keep going?
We could have kept going. If you
I
want.
want somebody else to go.
We can
work on
stop.
that
Okay, go
second.
5 more minutes.
Okay, so was this was the equation that you came up with and it works for
Yeah.
everything?
Well, I don't know because now I do it, but then I don't know. Maybe somebody else could.
So is there another way you could write it in simpler form?
Maybe.
What's N?
Yeah.
So it would be 3N minus 3.
And then
3n minus 1 plus 8.
minus
No, you
Oh, minus 3.
Like the number of pieces.
So then it would be 3N.
So could you use this equation to plug it in for any number of cuts?
What's N?
Yeah, what did you guys say N was?
The number of cuts?
Number of
Maybe it's
cuts.
n plus 1 and it's the number of cuts. Because how many cut? If you cut 4 times, you get 5 pieces.
Total number of sides.
Oh, the middles, Melissa.
N is the middle?
N is the number of cuts, and I did minus 1 to get the middle pieces times 3.
Okay.
So N is your number of cuts, and then so if you have 4 cuts, you have 3 middles. If you have 3 cuts, you have 2 middles, and then you multiply that by 3 plus your N, which is 8.
Okay. So yeah, that's the 8 right here. But then
So
once we
that
added
finds
that,
the
it
total
did.
number of ice faces?
Yes.
Did anyone else find anything different than that?
So N minus 1 is the middle.
Yes. If that, yeah. So this is the middle pieces you're saying? Okay.
How many?
Oh, I see. So how does that relate to what we had on the chart over there?
It does.
Well,
Because it's the number of cuts minus 1. 1 minus 1 is 0. Doesn't work for 0. 0 minus 1 is negative, but you can't have a negative piece of cake, so that's 0.
Right.
And then 3 minus 1 is 2, 4 minus 1 is 3, it would go all the way down. That would be that.
The
3
middle pieces
ice
are always
spaces.
3 ice spaces column.
So does everyone agree with this?